Thanks, Max, for the introduction, and I will share my screen. I will probably rush a little bit through the first pages to use the time on the latest technologies that we are in. So Gore is known for Gore-Tex. We are the inventor of the Gore-Tex membrane. We are 13,000 associates worldwide, and still one of the 200 largest privately held US companies. We did a lot of inventions and known for our culture. We're doing this in all kind of industry, from aerospace into to the body. And we are doing this with venting solutions where we believe there's a high potential for safety. Every enclosure that is sealed, from electronics, sensors, gearboxes, and more and battery modules, we have venting solutions and battery insulations that support in this area. And not only on the residential level or the CNI and grid level, we're doing this also in the automotive industry with some other products that we are having. So the main part that we're known for are the protective venting. So within the battery packs, power electronics, or other sealed enclosures, if you're having fluctuating temperatures or changes in attitudes, this could create vacuum or excessive pressures that threaten the seal integrity of the enclosure. And for this, the pressure equalization helps to reduce the condensation in that sealed enclosures while keeping the solid and liquids out. So this is what we're known for. This is similar working like a Gore-Tex jacket. It's breathable, it keeps you dry, it keeps your system dry, and also your battery pack dry. So we have a kind of sample where you see the one of the snap fit ventings. The latest version have a 3 times higher venting capability than the standards what you know so far. We are having this also in the big battery modules in the automotive industry. We are having different kinds, adhesive vents, weldable vents, snap vents, screw-in vents of all areas, up to the big screw-in ones that we're using also for energy storage. But the latest concepts that we develop for safety are 2 concepts. One is the Gore burst vent. It's a combined pressure equalization vent with evacuation venting capabilities. And you all know the lithium-ion batteries. If they once enter a thermal runaway, the internal cell temperature rises, vaporizing the electrolyte and causing pack level gas pressure to rapidly increase. And this is concerning the highest safety hazards, what we've seen in the picture before. And for this, a reliable and rapid release of the internal gas is necessary to release the pressure. And for that, we have a new invention. This is a double functional vent. What you see here in the video is a standard vent that it's bursting if a certain pressure is reached. And there's also slow motion where you could see how the dome is building up, and then the vent is bursting like a burst disc. But this is not the disc itself. So the whole breathable layer is stick to the battery enclosure with 2 adhesive layers and a proprietary activation layer. This activation layer, this is bursting if a certain pressure is reached. So this benefit in using a dual function vent by having only one vent with 2 functions with a consistent activation performance, and you're having greater design freedom because of the low profile part with the smaller diameter and a lower weight. So this could simplify the design and reduce costs. So at the end, with reduced complexity and cost through a simple, reliable dual function vent, we believe that we could support here the safety in battery applications. And the latest version, what we are bringing to the market and what was the safety concept, is the Gore battery insulation. This is the thermal protection, and this works when it matters most. So what you're having here is a thin material, 1 millimeter thick in standard, but we could also produce it in 0.5 millimeter thickness that has a low thermal conductivity at elevated temperatures, and it's stable under pressure. So it is not compressible, or the compressibility is really low instead of other solutions what you're seeing in the market. It's not particulating, so it does not require any kind of encapsulation. It's locally manufactured in all regions, and it's bondable. So what you could see here, the material is on a reel. Yeah, it's a soft material. It's a composite out of an expanded polymer and ceramic. You see the flexibility, the highest precision. It's less than 100 micron thickness variability, and you could have it in roll goods for automated production processes. And to bring it in the last point to compare it, why we believe it's helping to stop the thermal runaway propagation, this material has a different behavior compared what you having, for instance, with aerogels. So the material provides really the reliable protection on high temperatures. What you see here is a heat and trigger cell that is applying temperature. You're putting the insulation material in between and have a cold sink and the adjacent cell where you could measure the temperature too. And what you see, the temperature peak is not going higher when you use the right material. But the most interesting thing is if you compare it under applied pressure. So if the system starting with a thermal propagation, the pressure is increasing internally, so it's compressing the systems. So, and what you could see here that if you're using an aerogel, that due to the compression and it's getting thinner, the temperature is rising. And this is the big benefit of this material due to the fact it's not compressible. So you have an efficient and effective tool in large format battery cells with that unique combination of thermal performance and mechanical integrity. This stops thermal runaway propagation without sacrificing energy density. So you could bring more material in because of the thickness. So, and as last point, this is a picture of one of our partners that did a test. So they initiated thermal propagation at the middle cell. And in this design, the GBI is placed between every third cell with compliant pads for cell swelling in this case, and in the insulated junctions. So what you could see here, although the thermal propagation was initiated, this material stopped the thermal propagation at this point. So this was more or less everything in a nutshell. If you want to have more information or sampling or follow up, please connect with us. You see my contact data and also the product specialist, Greg Janutowski's numbers here in the chat. And I'm open now for discussion and hope I don't overspeed that much.
Well, you have been a little bit over time, but thank you very much for your insights. And I think since we are quite good with our time, there's still room for a question or two. Maybe let me start with the first one. You presented 3 different ways of improving the battery safety. Could you maybe rate them on the impact on the safety, let's say for preventing a thermal runaway, just for me to get an understanding how important each of these steps is?
So if you were in a standard mode, yeah, and you need the venting because of the different changes from temperatures and the pressure, and to avoid any kind of material that get inside or the humidity or liquids, then a standard venting is the standard what you definitely need in an encapsulated device. So this is the minimum what you have. If there's anything where you experience over time that a thermal runaway propagation or anything else could happen, or that tends to reach higher pressures, and you want to have a kind of safety device, then the Gore battery, the Gore burst vent will be the next step on top. And in the whole battery modules in between the battery packs, and you want to reach a high energy density, the Gore battery insulation would be then the final step on getting more safety to the system.
Right. Thank you very much.
If there's time, I would also like to add something because I'm intrigued by the second one, the second innovation you had. Is it a ceramic material, Gregor?
So the Gore battery insulation material is
Yeah.
a combination out of an expanded polymer and ceramic material. Yeah, but it's combinable with other materials. So I don't know if you could see it. So this is, for instance, with rubber pads, we try to create any kind of composites. The material is usable with many other things. So.
Okay, but it's not applicable for mobile application because you specifically mentioned BESS, or?
Yeah, so it comes out of a direction where we have invention also in electronics and mobile stuff. Also it's a PFAS-free product.
Okay. Good. Yeah, thank you for the honest answer.